Okay, so now today is we're going to do the SPM paper. Okay, so the question you can refer to your WhatsApp. I sent I think the WhatsApp group. I think you can see it from there. The questions paper to it. I tried to pin it. Might have gone up a bit. Tell me if you can see it. Uh, good. Can see right? We are using the one I sent in WhatsApp. Okay, good. So now we can start already. Let me see. Let's share screen. Entire screen. Uh, okay, so we are going. Let me see. Okay, so this the first question. Basically, we're going to do. Okay, so if you see this directly, what topic is this from? Like what chapter? You think lah, which chapter will it come from? Unstable. Hello, can you hear right? It's okay, it's okay. As long can hear, it's good. Can right? Okay, okay. So we do here. Okay, so this one now you tell me. This question. What chapter is it actually for this one? The first thing that comes to your mind lah. What chapter is it? Quadratic, not really quadratic. Is in Form 4, one of the chapters. You remember your yeah, correct. Simultaneous. Yeah, that's the one. So that is chapter 3, Form 4. So that one is different from quadratic. You must differentiate. Quadratic is chapter 2, Form 4. This one is chapter 3, Form 4 after quadratic. So this is simultaneous equation. So what I will do is I will show my solution lah. Then I will tell you where the marks are coming from. So this is how we'll start with this. So basically, this is a question where you should get full marks. Because 5 marks, this is basically the most easiest section to score in your paper 2 because it's just simultaneous only. So this is the SPM lah, the what most recent one your seniors set for. So this is the first question. So when you start with this first question, this question should actually give you motivation lah. Because if you can know the method to solve, then you already have 5 marks in your hand, precious. So yeah, so you must know the methods lah, basically. So this is how it looks. So can you see my distinct screen? Can right? I think you can see the solution. Is it okay? Can see. I think can. So wait, I use the pen. Okay. So now we will do I'll show you where the marks are going from. I'll also explain how it's all. So okay, wait. Okay. So this one, right, you have 3 equations, right? 4x plus y plus 2z is 0. So now in this chapter, we're always talking 3 variables. Be aware, not 2 variables only. Usually, the second subtopic, we will have like 2 variables, like we substitute linear into non-linear like that. So this one here, you see all the 3 equations, right? You see the second one, negative 2x plus 3y plus z is 8. So 3 variables or so. Wait, you're using substitution. Yeah, correct. Yeah, because I use substitute 4 into 2. So I'm using substitution. Yeah, that's good. So you can identify the method already. So this one make a correction. This one there's something wrong here. The third one is x minus y minus z. The correction is negative half, not half. The bottom one. Use the top one. So we'll use this equation. So first one, I just write down to give the examiner a clue how I'm starting with this question. So I just copy back 1, 2, 3 like this. And then you must give these kind of keywords to the examiner, like from 1, substitute 4 in 2, you understand, right? It's like we tell how is our what process of thinking to solve the question. So yeah, so here I express the first one lah. Usually we will express the one that are single terms, right? See like y, z. So you can choose anything from here, x, y, z. So I chose from 1 lah. So let's say I'll get, when I shift here, you will get negative 4x minus 2z. Both of these you bring here lah. This one also you bring here. So you will get negative 4x minus 2z. So this is where you get your first mark. So this is where your first mark is 1 mark. So when you can show like this, you already get 1 mark. Means anything lah. Doesn't mean if I use this one only I get 1 mark. Means like you express any of the equation, you put like this from, let's say from 2, z equals at 8 plus 2x minus 3y, you also get 1 mark like this. So it's not fixed lah. It can be anything. Then the next mark is coming from when you can reach to this. So from here you need to substitute lah. So which one you think you want to substitute into? Like this y equals negative 4x minus 2z. You want to substitute in 2 or 3? You got 2 options. 1 you cannot lah. 1 you substitute back, you get the same thing. So which one you want? Either 2 or 3 lah. Let me see. Yeah. Both also can actually. So which one you prefer? I think you want 2, right? Yeah. So I think we follow 2 lah, because you see, right, the what? We express y, right? So we want a simpler equation like 2, isn't it? So what I did is I substitute the y is negative 4x minus 2z inside here. So what I get here is, remember you can expand, make sure you know how to expand this equation. When I substitute inside here, the y equals something, something. Okay. We need like single variable. This one, when we substitute, right, you still have 2 variables. If you see, you have x, z. Still cannot solve yet, because you see, we have 2 things like x, z. You see in the final answer here. Means after this, you have to substitute again. 2 times we need to substitute. See, when you get here, we have to substitute number 4 and 5 into the third equation. Because if you realize, right, number 4 and 5, we have x and z term. And then from here, we have z term. And then if you substitute into 3, right, you already won't have the y term. And then you already substitute the x away. So you only have the z term in the end. See? And I come down here, right? I only got single variable z, z, z. Only when you have a single variable, you can actually solve the question. You understand now? Yeah. So that's good. Okay, so the second mark actually comes from here when you show this one. So 1 more mark. So okay. And then yeah, from now on, all your marks come from the answers, because you have 3 answers, right? Here in this question, you want to find the value of x, y, and z. Whenever they say solve, means you want to find values actually. The keyword is actually values. And they say the word solve, values. So now you want to find x, y, z. So now you have to substitute, right? You can understand this step, right? How I get from here. So I substitute this inside number 3. Right here. I put that inside there. And also number 4, I put inside 3. Means 2 equation I substitute inside. Okay, okay. Okay, good. So you understand already. So yeah, from there you need to be careful. Make sure you put this bracket, so that the negative sign, you don't make a careless mistake over there. Because you see right here, when you substitute negative 8 minus 5z or 14, the minus y. So when you minus y, right, you see here y is negative 4x. This one more part. Here you already got x, right? So you see, you can already substitute your x inside here. That's why everything down here is all z only, you see? Z, 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 that. So you have to, when you get this equation, you already put the x inside the on top one that you express. I must bracket another equation, right? Yeah, this one, right? You're referring to this part, right? Yeah, must bracket lah. Because you see, when I put negative here, see here, plus 2z. Because negative here and negative here is positive 2z. So that's why the bracket is important. Or else you will put minus 2z, which is wrong. It's actually plus 2z. So the answer will vary a bit lah. So yeah. So from here you have to do your algebra lah. Basically everything from here is algebra. There's no simultaneous. So how you convert from here to here is this one got same denominator, right? 14 and 14. So 14 and 14, what you can do is you make the whole thing over 14. You understand this part, right? Whole thing you put it over 14. So this one's like this, look. Okay. So this whole thing over 14, and then which one? Then you expand inside lah, minus minus plus 2z. Then this one, don't forget at the back here got minus z. This part here, minus z. Okay, so this one minus z. So you'll get like this. Then you minus z, and then okay. Negative 8 minus 5z. Okay, so how I convert from this to this is I actually times the whole equation by 14 times 14, because you realize here, right, at the bottom here I have 14. So I want to what? Eliminate this 14 out of from the denominator. So how you do it? Is you times the whole thing by 14, because 14 and 14 you cut, you get 1 only. So then so the top one remains lah, because it doesn't change. You times this by 14, this one will cut off lah. This one you cut, this one you cut. So that's why I copy back all this top one. This part you know, right, how it comes from. Things should be okay. So that's how the whole part comes from. And then this one, right, this part over here, where is it? From here, right, when I times 14, right, this one you get 1z, you get z only, right? At this part here, plus 2z minus z, you get positive z. So when you times 14, you plus 14z. And then here also you must times 14, don't forget your right hand side, to make it balance. So you understand, right? Okay. So this one is negative 7 lah, when you times by 14 the whole thing. And then you solve lah, you group the like terms, 5z, and then 14z, and then negative 20z, you will get negative 11z equals 33. So then 33, you will get z is negative 3. So this is where your third mark is coming from. So when you get your answer, z is negative 3. So that's how you group the whole thing. And then after this, when you get one already, one correct, most likely the other two you'll get correct lah, if you don't make any careless mistake lah. So from here, z is negative 3. You see lah, which equation you got want to find now. You want to find x, right? You can put the z inside here. So when you get z is negative 3, you put it inside the z here. Negative 8 minus 5 bracket negative 3. Make sure the bracket is there over 14. So you will get 7 over 14, 1 over 2. This is the answer. Make sure simplest form. Don't try not to leave it over here. Make sure it's in the simplest form. So 1 mark there. So okay, things should be okay. So after this, you get already x is half. So when you get x is half already, you have your x is half. Z also you got already negative 3. So you will finally put it inside here. So y equals, you want to put it, you can put it anywhere you want lah. Since we express y here, right? So we can put it over here, which is negative 4, and then x value is half minus 2, z value is negative 3. So when you simplify, negative 2 plus 6, y is 4. This is your third mark. So every value must be correct in order to get 5 marks here. So if you want, you can just make a conclusion like this here lah, for the examiner. Therefore, x is half, y is 4, z is negative 3. So this is yeah. 5 marks. 5 over 5. Okay. Understand? Ishan? Okay, good. So that's it. Look. That's your question. So fast, you see. One question done already, unmatched. 5 marks. Done. So this is your 5 marks. So now I will do a summary for this chapter. So let me see. So this one, if you're okay already, I'll give you some tips lah how you can make sure you can distinguish this chapter. So I stop share. So now we go to the whiteboard. Okay, simultaneous 5 marks. Good question. Simultaneous can actually go up to 8 marks depending on the question. So this question is actually considered low level like Avaswanda, because you see, right, they gave the equation like what? Straight away the equation, 3 equations. So now sometimes the question, you want to be tricky, they'll give you a situation, you have to form your own equation. You see here, you can see in your WhatsApp, they straight away give you 3 equations, but sometimes you have to generate these 3 equations first. So that's why you get 8 marks. When you generate 3 more, right, you get 8 marks. 5 plus 3, 8 marks. So yeah, that's how it works. It won't go more than 8 marks, definitely. Most is 8. Most is 8. Okay, so now you will do the summary. Any part that you don't understand, you can say, So chapter 3, form 4 summary. Okay, so what you need to know in chapter 3, form 4, system of linear equation in 3 variables. So this is the first subtopic you will learn. System of linear equation in 3 variables. System of linear equation in 3 variables. So this is the first subtopic. This is the question you solved just now. Means you mastered the subtopic already. So system of equation in 3 variables. This is the first one we talked about just now. So okay. Okay, so here you can use 2 methods to solve it. So the 2 methods are the one you mentioned just now, substitution, right? You said you can solve by substitution method. And then the one more method you can use is actually elimination. So don't fix your mind only to master one. Don't master one. You must master both also. So you must know this one. You must know, because in case in the exam you suddenly blank, right? You have a backup. Let's say this one you blank already. You still have this one to help you. Because both ways, so you can apply. Unless the question is specific, like they say, solve by using, let's say, substitution. So this one, no, cannot help you. If you don't know substitution, then gone already. So this is, if the question want to be strict, they can ask solve by using substitution method. So, but most cases, it will come out this, let's say, I'll say 80%. 80% of the time, they can assume freedom. So then this one, you can use 20%. Okay? So just be prepared, just in case. Okay, so that's your first subtopic. And then now is the second thing, types of solutions. Wait, let me see, types of solutions. Okay. So this one they can also ask. This one also is quite important. It has come out before in trials. So let's see. So there are actually 3 types of solutions, if you notice. It's actually in the textbook also. So one of it is no solution. One of it is infinite solution. One of it is one solution. So examples of no solution. Let's say I'm going to give you a number. No solution. Let's say I get 0 equals to 12. So is this possible? Can 0 be equal to 12? Shouldn't be, right? So yeah, so it's not possible. And then another one, infinite solution, 0 equals to 0. So 0 equals to 0 also cannot be possible. So this is why we call it infinite. Infinite solution, 0 is 0. Sometimes you might get like this in the exam, so don't be shocked. Sometimes you might think your working is wrong. But then you can also check back. Like here, there's two ways you can do it. You can check back. Or second way, remember your types of solution. Because this can also be one of the solution they want to test in the question. Okay. So, so now we talk about one solution. One solution is the common one which you solved just now, right? We got some values. So one solution you could get like x equals to 1, y equals to 4, z equals to -2. So usually the solutions are whole numbers. That's why we call it one solution. Whole numbers means like 1, 2, -4. You can also get inflection for decimals. So that's the common one you can expect. Fraction or decimal. So yeah. So don't only fix yourself to getting perfect numbers like this, 1, 4, -2. Can also be improper fraction, -8/7. Usually we leave in fraction, like if it can be converted to fraction. If you cannot leave it in decimal, they can also ask like give up to 2 decimal places. 2 decimal places. So you have to follow the question. 2 decimal places means like 0.89. So you stop here. Even though got something at the back here. So yeah, this basically how they can ask. And then next subtopic is simultaneous equation. Simultaneous equation in involving one linear equation. So involving one linear equation, linear equation, what you need to know is x must be power of 1. And then also it can be one non-linear equation and one non-linear. Non-linear means x power 2, x power 3, x power -1. Anything else except x power 1 is non-linear. That's why you won't get a straight line like this. Non-linear can be like this. Goes like that. So non-linear will look like that. And then this one here, we will apply 3 methods here. So it can be substitution, elimination, or graphical. So these are the 3 methods to solve this kind. So usually we will start linear to non-linear. Yeah, because it's the simpler one to the harder one. Don't start the other way around, because it can more complicated. So graphical we rarely use. Usually we will come back to substitution and elimination. But in this case, I will prefer substitution over elimination because the powers are different. So always think of substitution as your first choice. Substitution I put as number 1, elimination as number 2. So yeah. So yeah, that's the chapter about. Okay. So I'll send this on the group. Okay, so first we have a break for a while. 5 minutes, 10 minutes around that. So you can do anything you want first, okay? Can have your any break or you want, okay? Good. So you can go anywhere you want, like toilet break or anything, okay? Yeah, I know why. Why? Oh, really? When? Oh, recently. Oh, today only lah. Because he was there just now in the school. Oh, I mean, oh, we'll be okay. Ayo. How you know? Wow. It's okay lah. Just what wish him speedy recovery. Think you can get better. You can go first. You stay in the meet, but then you can like what this thing you can go for a toilet break. Later we talk more about it. I also want to break for a while. Okay. Chan, you back? You start now. Okay, good. You back with you. Okay. So I'll continue with the tips lah for chapter 3. So now this part is the summary we done already lah for chapter 3. Now I'll give you some tips how to answer the question. So let's see. So I'm calling Tanush so just in case, because he wanted to join, so he might have forgotten, I think. Okay, so now this is the tips. Oh, maybe busy or something. He said he got something to do. Am I allowed to start? So, okay, the tips for chapter 3. Okay, so got quite a lot of things here. Actually, I listed down. Okay, the first thing I said is when you solve your simultaneous, right, you will get x, y, and z value, right? So after you get your x, y, and z value, try to make a conclusion at the bottom. But this one maybe when you solve right, your x, y, and z values will be scattered everywhere because the working very long, right? So when you give conclusion at the end, let's say like this, therefore x is 4, y is 2, z is 3, let's say. So it will make the examiner easier, because when you see this also, he can give you marks for this, because he knows what's your x, y, and z value, your 3 marks. So I say make conclusion at the end, so that's easier for the examiner. Okay, so that's the first tip. And then, so how you want to check whether your x, y, z values are correct or not. Y, z values are correct. So this one actually got two methods. One is the calculator one. I don't know if your calculator that chunky or not. Are you using the same one as this one? I'm not sure because got many models. This type of calculator. This one is the FX different one, right? I think it's the more chunky one, the silver one or something. So sometimes in calculator one, you can key in directly the equation, then so calculator one, right? You can key in directly the equation sometimes. And then they'll show you like your x, y, z value straight away. So that's one way to check, of course. Then see your x, y, z value. And another way is you sub back into your original equation. So what I mean is when I show you that example of question easier so that you know what I'm telling. You sub back your values inside. Where after you get your answer, right, you sub back into the equation they gave in the question. Show you here. The screen. I think from here you'll understand better. Okay, so you have this one, right? So you see you got your, let's say I take here, right? X is half, y is 4, z is -3, right? So you just sub it inside any equation you like. Let's say I choose number 3, right? I put this all inside to their respective position. We try and see with your own calculator. You see we enter, right? Wait, I'll show you. So x -3, right? We press together. X is half. I mean, not -3. X is half. X minus y. Y is 4 minus z. Z is, make sure bracket, minus z minus -3. You see, you get -0.5. See? And type the whole thing out in the calculator. See, -0.5 is -half. Then the question here, see, equals -half. So this is how you check your x, y, and z values, whether it's correct or wrong. See, simple trick. When you get your answer already, you put it back into the equation. Make sure it satisfies all three, not only one. Sometimes one dangerous can be coincidence, but all three satisfy, then 3 times is not a coincidence. 3 times means it's correct already, your answer. So that's how you check in a simple way. For this one, you can check. Other things like log all, not really. This one can. So this is a useful tip for you. Okay, so now you understand this. Stop share. Okay, so you go back here. So this is the second tip. And then the third tip is one. So most of the time, right, try checking your final answer. So most of the time you will get as whole number. So what I mean by whole number is most of the time, not all the time is correct. Most of the time you'll get like the answer as x is 4, y is 2, z is 3. So usually you will expect as whole number your answer, but don't neglect the possibility it can also come in decimals. Sometimes the question is kind enough to tell you give your answer up to 2 dt. So you know already what you should get after solving those 3 equations is in decimals. If you get whole number, definitely you know it's wrong already, because the question gave you a hint already, you got decimal places. But if the question just says solve, then you won't know what. So it can also be a decimal. And again, it comes to the thing, sub back. So you still unsure, you sub back into 3 equations. See whether it satisfies. Satisfy all 3, then decimal also is correct. Doesn't mean it has to be whole number all the time. So don't fix your mind to one thing only. It must be more open in maths. Okay. So now number 40. Number 4. This one. So usually we always go from linear to non-linear. But sometimes the question will give like this: x plus y is minus 3 is 0. X squared plus y squared minus 2xy is 6, let's say. Sample question. So you see x here power 2, x here power 1. So it's definitely easier to sub x inside this power 2 and then expand. And then finally you will form quadratic. So you understand this part, right? We start from a linear one to a non-linear, so that easier for you. You start this way, it's going to be hard because you will get x squared equals something, then you have to square root, then only you sub the square root inside that. So that's why I don't advise this one. Don't, it's difficult this way. So always go from the lower power variable to the higher power variable. This one is the power. You see x nothing, right? Means on the top is power 1, but here x square, right? So it's power 2. So lower power means power 1. 1 is less than 2. So that's why I said we start from here to here. Okay. So that's the fourth tip. And then the fifth tip. Yeah. So you cannot, your quadratic is okay. Don't I ask first, just in case. Quadratic function. Chapter 2, form 4. Just ask as a random question. I think if okay, then this one can. If your quadratic is okay, then should be okay for this question. Because the 5th tip is you need to master your quadratic. I think that one is the most important thing. Master quadratic. Because finally, right, when you expand from here, right, you'll finally form a quadratic equation. So from there, you need to know how to solve quadratic. So quadratic is 3 methods, right? You factorize or use the formula or completing the square, 3 things. Okay. So from there, that one got separate question. They'll ask complete the square. So one of it is factorize. Another one is formula. Another one is completing the square. CTS, short form, completing the square. So that is your 50. And then the 6th one, this one, algebra. Master lower form algebra, like how to rearrange the equation. So I think you know this, right? I think should be okay. How to suit the equation to form quadratic like that. So this part you need to know how to rearrange algebraic and rearrange equations. Rearrange equations. So you must know how to shift from this side, from positive here, you shift the other side, come negative. if this one x equals x or y equals 3, you must cross multiply the x sign, and then another one is what? dy. Let's say it's multiply, right? Two numbers. One number you want to shift, the other side is divide that number. So those are the basic things lah by algebra. And then the seventh one is so basically, right, this chapter is a basic to a lot of other chapters in maths, if you realize. So that's why they put it in chapter 3. They put it at the front for a reason. So that's why you need to know how to solve simultaneous. Because in any chapter, if they ask you find value of h and k, you got two variables, right? So two variables means definitely you have to use simultaneous. You have to form equation, then choose what method you want. The first part of the question is the content of another chapter. Let's say indices, they want you to solve simultaneous. So first you need to master indices. Then after you form the equation, this chapter will come into play. So they can combine questions from various chapters. Up to 3 chapters combined can come in one question. It's only 2. So that one's harder question, I'll say. So some of the chapters are like indices, SURDS, and logarithms. This one can involve simultaneous. Progression can involve simultaneous also. And then coordinate geometry, simultaneous also. Vectors, simultaneous also. And then circular meshes also got simultaneous. Differentiation also got simultaneous. So you see how many chapters, right? And the basic comes from this chapter. That's why this chapter is very important. Because it can cover up to 6 chapters, the knowledge in the whole maths, Form 4 and Form 5 combined. So that's why I say this chapter, you need to know what methods to solve the question. So that's your 7th tip. 8th tip is what I told you. Make sure you get all the marks on this one. It'll help a lot. This one will come in your paper too, most likely in the first question. As we know in our trials, it came already, right? In the school trial. First question itself, simultaneous. You see, it's very popular. Even SPM, you see, it came as the first question. See the pattern? You can notice the pattern already. You know, this question will always come in number 1 in paper 2. So there you notice already. So yeah. So that's the 8 tips. That's all for chapter 3. Then you can understand better already. So yeah, these are all the tips I have. Simultaneous is the goal. Why simultaneous is the because it relates to many chapters. Good one. Okay, so yeah, that's our chapter 3. Now you'll go to second question. Do you like indices, SURDS, and logs or not? First question. Before I proceed. Because the second question in SPM was what? Logs. The question, yeah, correct. Indices and log. Maybe I can guide you from that question, like understand more. I mean your basic knowledge now. And well, I don't know how to do that. Yeah, it's okay. We learn from this question. This is a good chance to learn from question, not just by notes only or teaching like that. We learn from question directly. Okay, what? Wait. All right. I thought wait. Okay. Now we go question 2 already. Well, that's why I always cover the easier questions in your paper 2 first, like the first question. Will give you a lot of confidence because you know, right, in the exam, what scenario, the pressure is great, right? So if you start difficult already, your confidence is going to drop already. So you're playing with mentality. So if you start difficult, your confidence is going to drop. And then your easy question, like just now I did, you also cannot solve already. But if you start easy, right, your confidence level is going to increase already. Then the difficult one also you might be able to solve, who knows? Because you're already confident, but that's why maths needs confidence. So yeah, so I start easy question first, then go to the difficult one. So that's my tips also on what tip. Okay, so now we go this one. Wait, I show the question first. Number 2. Okay, so this is the question now. You see, right? First question itself, they didn't ask you to solve anything, you know. You see, is SURD 0.25 a SURD? Can you did you expect this kind of question or not? 1 mark on this, like a theory question. They're asking is SURD 0.25 a SURD, justify. So what you need to do actually is you just type SURDS 0.25 in your calculator, you get 0.5. You get 0.5 here. So actually 0.5, you must know the first concept that SURDS are actually irrational numbers. SURDS are irrational. Okay, so this is the first thing. When you get a number like 0.5, right, it's actually rational because 0.5 is actually 1 over 2, right? 0.5, never used to this. 0.5 is 1 over 2. So when you have fraction, right, fraction is actually considered as rational. Rational numbers are like a big group of stuff. You can include decimal, fraction, and normal numbers. So you see, when you get fraction, right, it's already rational. But all surds are irrational. That's the concept we need to remember here. It's a theory, kind of a theory, nothing to solve here. So this one is fraction. So remember, all surds are irrational. So that's why you see the answer here, square root 0.25 is not a surd. Okay, so you must tell that first. Hey. Not straight also. Okay, so not a surd. This is because it is a rational number. Because see, this is the reason. So 1 mark only, what? So nothing much to explain. So just 1 mark. This whole thing you get is 1 mark. Okay, simple. But this one you must know because it's a fact question. Okay, clear with that. No? Things should be okay. Now we go to your log question. B1, proving of log. So this one, how many marks? Let me see. This one is 1, 2, 3 marks. 3 marks for B1, 3 marks for B2. So total you get 6 marks. So now they ask to prove, right, log AB is log CB over log CA. This is one of the rules of log. So what you need to know is be familiar with the laws of logarithms, okay? So this is one of the rules where you want to switch the base A, right? Down here they put log AB. So you want to switch the base, you add a new base, log CB. C is a new base. And then you have to divide log CA. Means the pattern is you add the base over here. Wait, connect to battery first. Battery is low. Okay, so the thing is here, still there. Okay, so this one, so this one is the log. So when you add new base, right, you have to like log CB over log CA. So because the log is AB, right? So when you add new base, you put log CB, the first one over here, B here, then you take the A. That's how you do the log. Okay. Things should be okay. So now we go to the working part of it. So how we do it is we have to let this log AB, they ask log A to prove log AB, right? So we start with log AB. Let log AB equals the random variable of X. Then only we can start to prove. So here to here, you need to remember another law. How to convert log form to indices form. So how we convert is A power X equals to be A must shift here power X equals to B, not times, B equals A power X, then A to the power of X, okay? So after you get this, log C, you add log C to both sides. When you add log CB, right, means you also have to add log C to this side of the equation. B equals AX, A power X, so log CB equals log C, A power X. Notice the pattern, how they play with the log. So log CB is, you can bring down the power. This is another rule of log. When you have a power on top, you can bring it down. Means log CB is X times, this one is times in the middle, okay? X times log CA. And then finally you get X is log CB. Here this one algebra you bring this to the other side. This divide okay? This side is divide. So X is log CB over log CA. And then what is your x? You already said at the start, right? The assumption x is log AB. So x, you replace it with log AB. Log AB is log CB, copy back over log CA. Then you have proven it. When you finish proving a question, you write proven. Okay. So that's how you answer lah. Proving question. Understand? Things should be okay. Good. Very good. So this is your 3 marks. So I show you where the marks are coming. Okay. First one, your mark is convert your log form to indices form. So when you apply a law of log, right? This is a law. When you apply a law, you get your mark because that is your knowledge. What? So you get marks for your knowledge. And then next mark is bringing down the power of the log. This is also another knowledge. So you get 1 more mark here. Hey, oh my God. It's 1 more mark. 2 marks. The last mark is you show it's proven. This part, last answer. Here, 1 more mark. So here is 3 marks. Okay. So next one is the second question. So they ask to express. So express means don't find values. Express means you still leave it in an equation form. Means something equals to something like that. That's how you should get your answer. In as a single log. Single log means just log something like log. Let's say log a power b. Base a and then b on top here. So this is a single log. In base 3, remember. So here they gave as in base 3 and base 9. So what you need to do is base 9 here, you have to convert to base 3 because the question asks base 3. Here already base 3, so you maintain. Just continue down like that. So how you solve this? Log 3h, you see I maintain from here. Plus log 9k. So that you apply the rule here. Add a new base. Log CB equals log C AX from the B equals AX. So you see I apply here log 3k means you apply log 3 to this k, then log 3 to the 9 at the bottom here. Log 3k over log 39. And then from here, right, there's another rule here. You see 9 can actually become as 3 square, right, if you notice. Then you have to play around now with the numbers. 9 is actually 3 square indices. So you get 9 is 3 square. So you see you get log 3 square. And then you see the power here, right? Which step? This step. You see the power I shift down. Log CA power x. The x I times log CA. Means you see I bring the power down. That's one rule of log. You see I apply it here. Then log 3 square. I bring the power to the front here. 2 times log 3. Actually I skip 1 step lah. So from here you will get 2 times log 3. So log 3 here is actually 1. The value is 1. So you take 2 times 1. That's why I get 2 here. 2 times 1 is 2. Everything log with the same base here and the number here is 1. So now if you don't believe me, I can show you with this part. As log share. So you can see the calculator. Calculator can only work for log 10. Now remember, you cannot solve this thing in your calculator. But wait. Your calculator might be able to get log 3. I think I'm not sure because your calculator is Changi one. I'm not sure. But for my calculator, like you see, if I put log 10, our calculators all are in base 10. So you see, if I put log 10 right inside, means I'm actually putting log. The bottom one is 10 and then 10 here. You see, I click 1. That's why I said just now that log 3 is 1. See, the calculator proves it. Log 10 is 1. So that's why that one there, log 3 is also 1. Anything same base down there and then another number. So same 1. Everything is 1. Okay. So that's the thing. Now I share back. So it look like this. Okay, so from here you get log 3k over 2. So here, you know, right, is 1 over 2 is actually a fraction, because you see log 3k over 2 is also 1 over 2 log 3k, because log 3k is just a single thing here, means it's 1 times log 3k. So 1 over 2 at the bottom. So you see, that's how I get to here. And then based on the indices rule again, I move the half on top here just to modify lah. Because from here, the power, I bring it down here, right? It means I can also reverse the process. When I put the power down there, I can bring it up. So that's how I get log 3h plus log 3k power 1 over 2. Okay, so just the inverse lah. And then later when, this is another rule, same base, make sure same base, log with the same base and then plus in the middle. So when they have plus in the middle, these two you can combine, means times h times k power half. So you get hk power half. Then algebra lah. Let's say like a times b. You get ab, right? That's your answer. A times b is ab. The same thing here lah. Only thing they add a power half on top here. So you just copy back hk half. Yeah, this is your answer. That's how you express. You don't need to solve. This is your final answer. So where you get the marks is when you add the new log. Wait, let me see. This part. So this part's 1 mark. And then the part where you convert the log 3k to this one. This part is another mark. And then your final answer, of course, 1 mark. Okay, yeah, this is your log. One whole question done already. So this one is total 7 marks. Okay, you know, 7 over 7. So log is not that hard to score actually. If you remember the rules, you see all the whole question I played is on rules only. The rule of log. So you must go through your textbook lah. The textbook has the rule of the log. But also share it in the summary later after this. So yeah, read the summary at the back of the textbook. It's very good because they tell you generally about the whole chapter. You don't need to go through the whole chapter. So that's how it is. So now we will go through this thing. So far, okay. Stop share. Go to the board now. Wait, no? Okay, we go to the board now. Now start with the log summary. After every question, I said different chapters, right? So I will do a summary on it, so that's easier. Wait, this one. Let's take a picture of this already. Yeah, I did. Okay. So now we will do log summary. So this one chapter 4. By the way, Bhuvan, today class till 6:30. Just half because we started 4:30, what? So 6:30. Then we can cover a bit more. So this thing is like this. So summary of chapter 4 form 4. So indices, surds and log. Chapter 4. Okay, form 4. So this one is one of the chapters you need to master, so no choice. Okay, so I will tell about all the three. So this chapter is basically indices, surds and logs. So the name itself is like this. So I divide into 3. So from here you have to memorize how the laws, law of indices. Okay, law of indices. A to power m times a to power n is a power m plus n. This is the first law. Indices. So I'll give you an example. Like say I put 2 square times 2, 3. If I follow is 2 power 2 plus 3, which is 2, 5. So you can try in your calculator also. Let's say we try 2 square times 2, 3. Let's say I do like this. Okay. See like this, right? 2 square times 2 power 3. So I get 32. And then applying the law, right, I get 2 power 2 plus 3. Don't I also get 32? Yeah. This is where the law of indices comes from. So when you apply a law, both sides must be equal. So that's how maths is. That's your first law. Okay. And then the second law is divide. Whenever divide the indices means you minus the power. A power m minus n. Example, too long maybe. On 2 power 5 straight. So this one, let's say I give you 3 power 3 over 3 square equals to 3 power 1. So you try again, 3 cube, right? 3 cube divide 3 square. You get 3. 3 cube over 3 square. Random example. So I apply the law. 3 must minus 2, the power. So it's 3 power 1. 3 power 1 is also 3. Proven second law. So you just put, when you have unknowns, you just put random numbers inside to test whether it's correct or not, this law that you applied. So that's one way to check also. Like the simultaneous law, I ask you to put back the value inside the equation, then you see whether both sides are equal. So yeah, that's the thing. And then next law is a power n bracket power n. It's a bit more complex. So what we do is we will times the power a power n. So example will be like 2 power, let's say 5 power 2. So based on the law, I should get 2 power 10. So we try the calculator. So 2, you also do together so that you get used to it. So this is the example, right? 2 power 5 and then square the whole thing. You will get 1024. All right, 1024, correct. So now I try 2 power 10. 1024. So see, this is the third law already of indices, and it apply already. So 3 laws already applied. Okay, so this is how you check. This one won't be in the formula sheet. Maybe I don't know this SPM how they will give the formula sheet. They can modify it from the previous one, but based on the new syllabus KSSM, right? Like the last year SPM, they only gave 21. So this one is not included. So you need to memorize. How to memorize? Practice question. First question will test you on all these 3 laws. So if you can solve the question, the correct answer means you already applied. You know all these 3 laws. And then continue practice so that you will remember it. Okay. So next one, law of surds. That's all. Indices, 3 laws only. 3 things to remember only indices. Okay. Next is the surds. So surds, surds we can actually relate it to indices also. Law of surds. So law of surds is first one, surd A times surd A, you will get A. So how to test it is, you know surd, right? Is square root like that. You say square root, what power you think it is? Square root, like say square root 9. What is the power of a square root? The name you can see it is square root square. What's the power? What power usually it is? I think usually don't say 2. 2 is not the right answer. 2 won't be the right answer. Usually square root A, let's say surd A like that, right? Like that. Surd A, usually what's the power? You think like anything, so can surd A. So surd A is usually half, right? So this one you must know. So surd A is usually half. So it's A power half times A power half. You get A power 1. Based on the law. So A power half plus half is equal to A power 1. So half plus half is actually 1 also. A power 1 equals A power 1. So it's proven, the law of surd. How to prove it again is put random values inside this calculator, okay? So surd 3 times surd 3. You get 3. Means you get the content of the surd. Surd 3 times surd 3, you get 3. That's why the general formula is surd A times A. Surd A times surd A is A. Means I replace the a value with 3. Just a random number. You can try with 2, 5, anything. Anything you want, you should get the same answer. So that's how another law comes from. And then another one, SURD A times SURD B is SURD AB. So how to prove this? You can also use your indices. A power half times B power half is AB power half. This one, the whole thing is SURD. Means the whole thing AB power half, bracket AB power half at the top. So how you do it is, when you have same power like this, right, you can times the content. So how to prove it is, let's say 3 times 5 power half. Let's say I have like this, right? 3 times 5 power half. Wait, power 0.5 lah. I don't want half. So 3 times 5 power 0.5. You get 3.872, let's say, right? So now I try 15 power 0.5. Yeah, same answer. So this is another law. So this is how you prove it. It's another number. So we will get A times B power half equals AB power half. So A times B is AB. AB power half equals AB power half. That's another law. And second last law, SURD A over SURD B is SURD A over B. The whole thing SURD. So how to know this? We try with random values again. So we try, let's say, SURD 3 over SURD 9. Because A and B must be two different values. Don't put the same number. So I try like this. SURD 3 over SURD 9. What I get? 0.57735. Okay, let's say we put like this. And then we put SURD bracket 3 over 9. One shot. Same answer. 0.57732. You see? Proven. One more law. It's 1, 2, 3. Third law. And then another one is your quadratic. You must know how to expand. A plus SURD B times A minus SURD B. So what you get is A square minus B. So how you do it is another longer way. Let me show you. So A times A, the pattern is like this. A times A, you get A square. A times SURD B, you get minus A SURD B. And then SURD B times A, you get plus A SURD B. And then SURD B times minus SURD B, you get minus B. SURD times SURD, you cut off. Means you get power 1. SURD B times SURD B is B. So I get B at the side here. Okay. So that's how you do it. And then from here, right, you can simplify. So when you simplify, right, SURD, minus A SURD B plus A SURD B, you cut off. Minus 3 plus 3 is 0, right? So same like this, minus A SURD B plus A SURD B 0. Whole thing gets 0. So the answer is A square minus B. Yeah? Same as here. Proven again. One more law. So that's how you must check. Make sure the left hand side equals to the right hand side. And then the last one, law of logs. Logarithms. Okay, so this one, that's how I shown the question there. You apply all the laws there. So how we apply it? This one. Let's say I use x and y as a random variable. Log base A xy is log ax plus log A base A y. That's the one of the law I applied there in that question. Okay, so that's one of it. And then log A x over y means x divide y. Okay, so you will get log ax minus log ay. This is your second law. Second law of log. And then third one, log base A b power n. You must shift the power down. Okay, so n log times log ab. This is your third one. And then the fourth one, adding new base. log AB is equal to, let's say I introduce a new base C, log CB over log CA. That's your fourth law. And then the fifth law is you inverse the bases. Let's say I got like good way to prove. Log 10, right? I want to inverse it. I type my calculator. Log 10 is 1, right? So I want to add a new, if I want to inverse it, right? So if I inverse the same base, I put 1 over log 10 also lah. Because same base, what? Then 1 also the answer. So this is why I say it's the same thing. Because you inverse also, you'll get the same answer. So let's say I got log AB. So I use AB. Log AB is 1 over log BA. So this one is actually reciprocal or something like that. And that's why the bases also must switch. Because 1 over means reciprocal. So yeah. These are the three laws. Yeah. So that's all on log. So basically the whole chapter is indices, surds, and logs only. So indices are related with surds, and I will say that indices are also related with logs. These two can be interrelated. This one can be related to this, and this also can be related to this. But surds and logs are not related. So they are separate things. So in order to be good in this chapter, basic is indices. Then only you can proceed to surds, because indices, surds related. Indices not good, surds not good. And then indices not good, logs also won't be good. So that's why indices is, so they put it at the first subtopic, what? Then only they put surds, then only they put logs. Means they want you to what? Master your indices first, then only move on to surd and log. Okay, so that's why they arrange the structure like this. So yeah, you must see the relation between all the topics. Then you get a better understanding. So now we go on to the tips for this chapter. In this chapter, quite few tips only, I would say. Nothing much. Because basically everything depends on the laws only. If you cannot master the laws, then cannot learn. Because it's not like simultaneous. It's not like something where you can like form equation, all those stuff. You need, the whole chapter lies in the laws. If you cannot grasp the laws, then can't proceed. The following steps you'll be stuck at it. That's why I say you must master the laws. So let me see. Tips. So first thing, it's not summary. Tips. From chapter 4 from 4. Okay, so first tip, surds cannot be simplified. Give yourself an example. Surds cannot be simplified. The example is like surd 15. Can you simplify surd 15? Definitely cannot. What? So you type surd 15, you will get like this. See how many decimals it has in the calculator. You can see already. It will come like this. Like this. 3 point until the end. Means it doesn't stop there. It continues going. It's just the calculator doesn't show how many values of decimals it has. So, and when you want to convert to fraction, you see you cannot. When you shift A, B, C here, you still get in decimal. Means it's a irrational number. They call it surds are irrational number. Means the decimals continue to go on till infinity. So that's the first tip. And then the second tip, master law of logs. Because logs were quite a favorite question. Actually, all are important because one question they can come out like part A surds, part B logs. So can infinity and beyond. Good one. Yeah, so good concept you have. Yeah. So next is master law of logs. That's why I said just now, I told you the law of logs just now, because the whole question depends on how good you can master all the laws. So that comes to exercise, constant exercise, and then can master law. So master law of logs, that's it. Common mistakes involving logs. Don't be surprised, it's not very common. Common mistakes involving logs, because you got so many laws, right? So sometimes you get confused, like times and plus, divide and minus, right? Even we so can make mistakes sometimes if you are like doing too fast in the exam. So these are the common mistakes I found. Let's say log AB times log AC is not equal to log ABC. Remember, whenever there's times in between, the law doesn't state you can times both of them. Like the law, only if it's plus here, you will get times log AC, you won't get log ABC. Only if plus in the middle, okay? First common mistake. And then another common mistake is, let's say I give log A bracket X minus Y. So you see minus, right? Suddenly you might think log A X over Y, because minus means divide. But cannot, because you see it's in a bracket X minus Y. So it's not equal to log A X over Y. How we must be to do this is, you must be like log AX minus log AY separately. They combine in a bracket like this, you cannot apply the law of log. Like log A bracket X minus Y inside. Only with log AX minus log AY, then only you can apply log AX over Y. Okay, so it's kind of algebra. And then this one. Okay, so third, fourth tip will be the third one. So fourth tip is, this chapter is greatly related to linear law. So I ask you a question: are you good in linear law? If you are good in linear law, you should be able to do this chapter actually by fact law, because they'll ask you to modify the equation in linear law. So in linear law, like how you draw the graph, all that very technical, right? What's that? Blank. Linear law got in paper too. That's why I like, because that's why you need this chapter to master linear law. And that's why I know this. That's why I'm not good in linear law, because this chapter is also related to linear law. So at maths, all the chapters are related. There's not one chapter. God, actually, there are chapters that stand on their own. Like they cannot find any relation. One of them is index number. Index number only, lah. Basically, that's it. That's the only chapter I can think that doesn't relate to anything. Permutation and combination. That one also I cannot see any relation. Yeah, I don't find any relation anywhere. Probability is related to permutation and combination, but that one stands alone. And kinematic, differentiation and integration, so it's related also. Yeah, that's it. So those two, yeah, that's why they come out in section C, right? If you notice, what index number is always in section C. So they stand on their own. So they ask you to choose that question when you do section C. Because that one, it doesn't involve knowledge coming in from other chapters. You learn that chapter alone, you can score 10 marks a day. Solution of triangle, you can classify it also as standing as its own, but you can relate with trigo, because sine, cos, right, is related to trigo. So your chapter 6 from 5, the most difficult one. Yeah, because trigo, what? Solution triangle means you cannot vary from trigo, what? Both of them come in one package. So yeah, only index numbers and permutation and combination. Other things all are related. Yeah. Okay, so yeah, this is the thing. And then next tip, let me see. Master law. Law of indices. Also greatly used in differentiation and integration. Why I say this is, you will see soon. As a relation also. Because you know, right, when you differentiate, right, you reduce the power, right, -1. Power, right, indices, like 2 power 5, you differentiate, you -1 the power. So it's related, to this chapter, indices, differentiation. Integration means you plus the power by 1. Means you need to know what is power in the first place. No? The power, how you remember, is indices. No? You can see the relation there. And differentiation and integration in between themselves are also related because one is plus 1 to the power, one is minus 1 to the power. So there you see how the whole AdMath syllabus comes like that. So you can see how it's related. So yeah. And then another one is this one. How to remember the law of indices. Multiply indices means you add the power. Divide indices means you minus the power. So always think of it that way. Times means you plus. Divide means you minus. Think like that for this chapter. But in fact, they are all 4 different operations. But just for this chapter, times means plus, divide minus. Okay. So yeah. And then next one. If you don't know how to remember law of surds, you don't know law of surds, how to like times them, right? You and I do this in the exams, like when they give a surd question, right? I put random number inside the variable. That is sub random number. Then you will get an answer, right? Let's say surd 3 times surd 9 is surd 27. You get the answer. And then in the variable there, you got surd A times surd B, and you don't know what is surd A times surd B. So you see the pattern, right? Surd 3 times surd 9, you get 27. Means at the bottom there, you must get surd AB. It is a variable, surd A times surd B. So you see the relation there? Always put random numbers inside. Then you will know already what's your answer. So sub random numbers. And then use your calculator. That one greatly helps in this chapter. Okay. So next one. Surds can be converted to indices. That's why I said just now they are both interrelated. Surds and indices. So if you master your indices, you can actually find a relation because surd A is actually A power 1 over 2. Means that is in the index form. If surd A is surd form, because you got the square root like that. But if A power half means in the indices, that's why you see it's interrelated. You can convert in between them. So that's how you master surd. And then most questions require quadratic. You need to master quadratic. This one is for surds. Relate to surds. Because on surds, you will actually form a quadratic equation. If you realize the expansion pattern is like quadratic. When you have two surds like that, you will surd one times, then this one times, then the bottom one you times like this, and the bottom one times like that. So you master quadratic, then the same thing really. It's just they are complicating it with a surd, square root something. That's it. Just a different form of number. But quadratic, they give you a value. This one, they give you like surd something, but actually as a value also. But they just express it in the form of a surd. That's why like you think something foreign, right? But actually not foreign. It's like quadratic only. Because quadratic, they give you a number. This one, they give you surd. So it seems like something very difficult. So next one, last tip. Progression. Good in progression or not? Chapter 5 form 4. Relation. So there's a relation with this. I hope you're good. Be good, okay. So basically, it's log can be related to geometric progression. So it's related to geometric progression. And why I say this is because sometimes progression questions, right? You got the formula, let's say Tn is A Rn minus 1. And then suddenly you will get an equation, let's say 5 power 3x minus 1 equals 19. Like the 5 power 3x minus 1 is 19. So how we want to find x here? How you find x is you apply log. When you get the equation like that, log both sides, log 10, only log 10, because you don't have other logs in your calculator here. So log 10, log 10. Then you shift the power down here. Then you can find your x, algebra. So that's how you need to this thing. Power x, shift down. So this how you do it. So then you find your x. That's it. Tips for chapter 4 done already. So this how you do it. So now we go to the computer. How come you raise the hand? You know. Oh, silap. Okay, so now we go to this thing. Question 3, let's see. Let me see. Share screen. I want to see what question is this. Okay. Question 3. Oh, functions. Okay. Functions. So functions, how? Good at functions or not? Chapter 1, Form 4, first chapter when you come into this advanced world is your first chapter, functions. Basic is composite, inverse law, all those things. I had TBY, very good. So now I know why. Okay, now we start. Okay, so now we see, right, got 3 functions here, right? P, Q, R. So how we see is x is related to x plus 2. X plus 2 to function f. We follow the arrow, arrow here, okay? So, not to insult her, I'm just telling. So, x plus 2 you relate to 3x minus 4. So, follow the arrow. Function g is mapping x plus 2 to 3x minus 4. This is how we say it. Function g maps set q to set r. This is how the question will tell you. Maps means where the arrow is pointing. That's what they're trying to say. This here also an arrow like this. Okay. So you see the solution. This part, be careful. Sometimes people will confuse. They write FGX because they follow here is F, right? Then you get G. Then you get the answer here. So you will put FGX is 3x minus 4, which is wrong. So because right, the order is you're starting with this first. This is first. And then this is second. This function is second. So when you start, always start with your right side. Right side, you must start with the first function you're doing, which is f. That's why it comes gfx. Means the second function is here. Go to the first function here. Opposite. Don't start 1, 2. Start with 2, 1. That's how your function comes with. So 3x minus 4. And list down your other info. So fx is x plus 2. Okay. So now the question asks gx. So how you master this is composite function. So because combination of 2 functions, composite means like very complex thing, combination of functions. So it's under composite function. So you sub in your fx. This one gfx, right? Means g bracket fx equals 3x minus 4. So this is what I did here. And then how you want to find gx? So you make an assumption. Let f minus 1. F minus 1 is f inverse. Anything power minus 1 in maths is called inverse. That's why like x power minus 1 inverse. So the graph comes like this. Okay. So you shift x equals fy. It means you want to bring the f here. Means from negative 1f, you want to come to f power 1. Positive. So you see fy here, what do you have? Fy you have here, isn't it? Fy is y plus 2. Because x you replace with y. Ganti lah.
So you get x equals y plus 2. And then you want to get f inverse x now. So how is you make the subject of formula as y? Understand, huh? So y is x minus 2. Okay. So now you conclude, f inverse x is x minus 2. And then what's your question? Gx. So now we realize, right? Gx is gf f inverse x. Means everything times together. Because you know why? F power 1. It's an indices. Then this chapter, so I found another relation. It's related to indices. So if you know your indices, you can do this chapter. So your composite function and inverse function. I show you here how it's related. Oh my god. Anyway. F power 1 times f minus 1. So you see here, f power 1 times f minus 1. You get f power 0, which is 1. So that's gx lah. Because f and f you cancel already. So you only get gx. So gx equals gf f inverse x. So f inverse x is x minus 2. This one. So this one 3 bracket x minus 2. Because f inverse x you have to sub first, right? So x minus 2 will come inside f inverse x. And then what is your function gf you found? Gf is 3x minus 4. So the x is you put inside here. So you get 3 bracket x minus 2 minus 4. So you get 3x minus 10. Yeah? So you see here. So there you will get, see your marks. So marks is, here how many marks? Let's see. 3 marks. So 3 marks. First mark is when you put your gx plus 2 over here, 1 mark. And then second mark is you substitute your f inverse here. And third mark, final answer, 3 marks. Okay. So now f square x. They want to find f square x. Means you double up your function f. So f square x is ffx. So ffx is f bracket fx. What's your fx? X plus 2 lah. So f bracket x plus 2. Then x plus 2 is, you must times. So you must times here lah. So x plus 2, then you plus 2 again. Because this is your function, what? X plus 2. So you ganti the x variable here with x plus 2. And then you plus 2 again. So you get x plus 4. Finish. One question like that only. See how short. 3 lines only. Done. Okay, so I hope you change your perspective on functions lah. Because it's not that difficult actually to master. 1 mark only. 1 mark. Final answer 1 mark. 1 only lah. And then they want f. They want now the second one is general form. Good. Can follow, not bad. I didn't teach this chapter, you know. I mean normal lesson lah, like we have we straight go here only. So now we want to form general, right? So now we just make an assumption. Let's say we want to find f cube x, right? So f cube, how you get? F times f squared. Indices again, the relation. F power 1 times f squared, you get f cube. Trying to cope. It's okay lah, slowly but surely. Can you just try more like what? Past year papers. Then you will notice the style. If you do by your own only, then you will know actually where's your strength and weakness. Because I cannot identify from your side, right? Because I never seen you a lot, right? So you must try on your own and then learn from your mistakes. So not only from my side, lah, your side also. So okay. So f times f squared, f bracket x plus 4. Because f squared we have here, right? X plus 4. Ganti lah, x plus 4. And then fx plus 4 you find here lah. Fx is x plus 2, right? So you ganti lah. X with x plus 4. There here. X you ganti with x plus 4. Then remember plus 2, because the function is plus 2 at the back. So you get x plus 6 there. So then you make a conclusion, because they didn't ask you find f cube x. They asked in general form. So fx, f square x, f dx. This is like progression. Another relation. Function can be related to progression also. Okay, so you need to master progression also to form general form. Okay, so you get x plus 2, x plus 4, x plus 6. So how is this? Arithmetic lah. Plus 2. Don't be scared lah. It's okay. Plus 2. And then here is plus 2. Plus 2 here. And then you conclude lah. F power n. N can be any power you want lah. Let me say. Any power. Any power you like lah. So they ask general form. Power. Okay, so f power nx is x plus 2n. Why I say x plus 2n is because n can be 1, can be 2, can be 3. When you put n is 1, right, you get x plus 2. When you put 2, you get x plus 4. Then x plus 2 power 2 bracket 3, you get x power plus 6. Then fx, f square x, f cube x. Then arithmetic progression. So yeah, you need to know how to form general form. So this comes from arithmetic actually. But actually your lower form taught you this also. So go back to your lower form also to master, not only arithmetic. Okay. So this one is 3 marks. Wait, how many marks here? 1, 2, 3. 1, 2, 3. Yeah, 3 marks. So 3 marks. First mark is x plus 4. This one got 2 marks. Oh, yeah, sorry. This one got 2 marks. This question. X plus 2 is another mark on top here. This one 2 marks. And then this one, when you get x plus, anyway, this question lah, correct lah. Then you get x plus 6 is 1 mark. And then when you form your general formula here, this part, make sure you have this, your final answer, 1 mark. Okay. So total is 7 over 7. Yeah. Done. 7 over 7 marks for you. So this is your function lah, master. Okay. So this is your function. And then now we go to the conclusion already. Blank again. Okay. Okay, so now last conclusion of it, right? I didn't take picture for this. Okay, okay. So now we do the conclusion for this chapter. Okay. So chapter 1 form 4 summary. So it's your first chapter in advance. So we've done the last now basically. So first thing you need to know in this chapter is function notation. So function notation is how you write like this. Function notation fx equals to 2x. So fx is 2x lah. This is a function, right? And then how to write another form is f colon x mapped to 2x. This is another function notation. So x is object. Remember x always object lah. So fx is image. Means x mapped to fx, means object mapped to image. Always like that lah. And then how you represent your function. Representation. Tons of lower form knowledge actually, but they include in admin. So how you can represent is in arrow diagram. Is sometimes the question will give you like this. General formula. Usually the other two one you learn in lower form, they don't test you here lah. So just remember these two. Arrow diagram, general formula. So I don't want to introduce the other two lah, get confused. So now we analyze functions. Discrete, continuous. So discrete and continuous, you analyze English term lah. You learn the meaning of the English word. Discrete means what in English? You try to define it lah. You search up the dictionary. Discrete is what in English? Discrete means like how to say, something like random. I would say random means like something here, not like in a pattern or something. Discrete is like lawak. I think in BM it's called lawak. Okay. So yeah. So discrete. Discrete, the graph looks like this. Discrete is your binomial actually. Chapter 6, chapter 5, probability binomial. Binomial look like this, right? The function, something like this. Like this, then like this, then like this. Px equals R, and then here's R. This is how discrete is. It doesn't have like a continuous curve. Whereas continuous, it look like this. Continuous can go like that. Continuous, like you form a straight line or curved line like that. So this is how function goes. And then composite function. Composite function. Okay, composite also you have to understand the word lah to understand what they're trying to tell. So composite function is let's say gfx is equal to g bracket fx. That's how they form composite function. So you have three circles. Circle, circle, circle. X, fx, g fx. And then now how you want to get from x to fx? Means you have to have a function, right? So the function label is f. So f here. And then how to go from fx to gfx? You see the difference, right? You add a g there. gfx, so g is here, huh? And then so the total is gf. Remember, always put your first function you're mapping at the most right hand side. So it's gf, not fg. Huh? So like that. And then from here, this is for this lah, what I told. And then another way is like this. X, three circle. X, gf, and then f, gf. So fgx. How to get x to gx? G la, function g. Then only you can get a function of gx. What? So g, and then gx to fgx. So suddenly you see a function f popping up, right? So you have suddenly an f. That means you have to have a function f. Look. So f is here. And then how to get from x to fgx? Fg means not gf, because first function you are mapping is g, not f. So the conclusion is fgx is f bracket gx. Okay, so that's the thing. And one more thing is conditions. Condition is one-to-one function. Only can apply to one-to-one function. One-to-one function is like you have a circle here, right? Let's say I put x, circle here, I put y. So one-to-one means one number here mapped to another number here by an arrow. Let's say function f. So that is one-to-one. Means one-to-one. One-to-one is considered a function. Anything that goes to one number is considered a function. So that's how we see it. Okay? So let's say this diagram. So this is the summary for this. Okay, so now how we do this, how to explain this is like this. Okay, so this one is, let's say fx map to y, right? F dot dot x go to y. So inverse function of this is f inverse x is y. That's why I showed just now in the question lah. That's how you see. So x and y, two circles lah. And then we get, let's say a number here is x, and then a number here is y. So we will get x to y is function f. So you follow lah. F dot dot x go y, right? Means function f maps x to y. This is how you read it. Fx arrow y, function f maps x to y. So I got arrow what? So like that lah. And then you want to go opposite means inverse lah. Anything opposite in admins means power negative one, inverse the whole thing. Okay, so it's like that lah. That's the whole chapter based on the textbook lah. So I took from the textbook the summary notes. So it's like that lah. And then some final tips before we end. So tips of chapter 1. You need to know the properties of inverse function. Yeah, it's a part of the tips also lah. Okay. Only restricted to one function. Remember, only one-to-one, okay? Other functions, other types cannot. Means one thing pair to what? Chun. Why chun suddenly? Chun. Okay. Only restricted to one function. Okay, so let's say f dx equals dfx equals x. So gx is the inverse function of fx. That's what we're going to tell you. Dx is inverse function of fx. So graph of f minus 1 is in with this one. They can't give in a question. So they gave in a trial like something like this. So x, y, 0. They have a function, let me think how it went. Going like this. And then you have a y equals to x axis, right? So how you draw the function, no, not here, sorry. The function touches at one point like this. So how you draw the other function is you reflect it on y equals x. It comes like this. See, reflection come like that. This is how it comes, the graph. Okay? So that's how we get it. F minus 1 is deflection of graph f in line y minus x. F minus 1 is reflection of f in y equals to x. So let's say I have a 0.01 on fx, means 1, 0 on f inverse x. So that's the whole thing. And then the two important tests that you need to know in this chapter: inverse function test and function test. Inverse function test. So if the curve, if some we use horizontal line, remember, don't get confused with another thing. Horizontal line. So one point, if the curve intersects at one point, means it has an inverse function. Means like a function like this, right? If I draw a horizontal line, it intersects 2 points, means not a function. Only one point is it has an inverse function. Same for the other one. If it intersects at one point, it has a function. Inverse function and function, same thing. Only thing, one is horizontal line, one is vertical line. Like 2 point, no lah. Like this, 2 point, no. And then function or not, you want to know function or not? Function test. So function test, 1 point intersect means function lah. And then 2 point test, 2 point intersect means no function lah. 1 point only is function. If 2 point anything, no, not inverse, not a function also. Okay. So tips: do not confuse g of x and x. Okay. G of x and f g x, because both of them different composite function, they actually mean a different thing. But there is a condition where g of x can also equal to f g x. Now you can prove it lah. But it depends on the equation they gave lah. So for this thing, master technique of inverse function, one more thing. Because a lot of people sometimes they forget the inverse function. Because the basic stuff actually, but master the technique because it helps in many places. Master technique. And then sketching gloves. Sketching gloves, you have many topics, but this one also has sketching gloves. So practice sketching graph. Okay, so you must know how to sketch graph. Second last thing, when finding gx from composite function, when you want to find gx, right? How to find gx from composite function gfx and fx. Once find gx, then you sub back inside the composite function. So how it goes is and complete the question. So you put gx, you sub inside the question, then you can find. That I showed the example just now, how to find the fx. Okay, and then inverse function, normal function. Okay, so last one, how to convert between inverse and normal. So inverse normal. When you go from inverse to a normal one is you go from a normal function to inverse, right? But you want to go from inverse to normal, to reverse the steps I did just now in the working that. Need to just reverse f inverse. This one is f. Okay. So this is how you can do it. So if one way you go that way, then the other way you go the other. F and f inverse. Okay. So this is the thing. So like that. Okay. Then you open your camera lah. So I take picture. You open your camera, I show that I take picture. If can lah, I take the chat box. Done already. Wait. Okay. Yeah, I stop recording. Stop recording.